So in this question here, we've got a tow truck towing a car. The tow truck is 2,000 kilograms in weight and the car is 1,200 kilograms in weight. Now, the driving force of the tow truck as it's pulling along is creating 2320 newtons by the engine and other means. There is a resistance force on the tow truck of 800 newtons and the car has a resistance force of 240 newtons. So I'm assuming this is probably drag and air resistance on those particular vehicles. Now we've got the tension in the tow rope marked here. Now from the tow truck it'll be going away from the direction of travel towards the car, and the tension in the tow rope at the car will be going in the direction of travel away from the car towards the tow truck. Now what we want to do is show that the tension in the tow rope is the same at both sides. Otherwise the gap would be changing or the rope would snap. And we're given that the acceleration as this thing is moving along is 2/5 of a metre per second squared. So as this thing is moving, our base setup for how we can do these calculations is Newton's law of motion, force equals mass times acceleration. So what we have to do is resolve for the forces and then set it equal to mass times acceleration. So in this case we've got acceleration given and we've got the masses of the tow truck and the car given. So we need to find the tension in the tow rope at the car and the tow truck. So let's do at the car first. So what's going on there? So let's do our setup, force equals mass times acceleration. Let's resolve our forces at the car. There's 240 newtons going in this way. So that is going against the travel. So that's minus 240. And tension is going with the direction of travel. So that's a plus T. And there's no other forces acting on the car at that particular part of our diagram. And we set that to mass times acceleration. Well, the mass is 1,200 and acceleration is 2/5, and it's positive as the thing is accelerating, not decelerating. And then we can see there we've got an equation with one unknown. These are numbers, we can sort of solve for that. So set our T equals 1,200 times 2 divided by 5. Well, 1,200 divided by 5 is 240. So we've got 240 times 2. And then add 240 if we bring that to the other side. So 240 times 2 is 480, plus 240 is 720. So tension in the tow rope at the car is 720 newtons. Okay. Now if we calculate it at the tow truck, we should have the same. So let's do that here. So at the tow truck. So what forces are acting on the tow truck? So we're just interested in what's going on here for the tow truck. So our setup again, force equals mass times acceleration. You can see that this is a great rule of physics and kinematics and everything. It helps us to solve so many things. Force equals mass times acceleration, so forces. So direction of travel, we've got 2320. That's the driving force, possibly of the engine and all the other bits. Going against it, we've got 800. That's the resistance force maybe. And obviously the drag on the road. And tension is also going against the travel of direction. So that's a minus T. And then there's no other forces. That's our three forces we've got there. Let's set that to mass times acceleration. Well, mass is 2,000 in this case. And times that by acceleration, which is 2/5. Okay, right. Let's see what we got now. So we've got one equation with an unknown. Nice and straightforward to solve. So I've got minus T. I've got 2320 minus 800, so that's going to give me 1520. And 2000 times 2 divided by 5. Well, 2000 divided by 5 is 400, times 2 is going to give me 800. Okay, now let's move this around and get our solution for T. So if we put T over here, it becomes positive. And we keep the 1520 and bring the 800 onto this side. And then we'll see that our tension at the tow truck is also 720 newtons, as expected. Okay, so we've shown there now that the tension in the tow rope at both vehicles is the same. Okay.